When you have an equation of this form, the graph would be circle, because 5, 0 is a point that makes it true, and 0, 5 is a point that makes it true, and negative 5, 0 makes it true, and 0, negative 5 makes it true. And there's also, I mean, at this point it could join to make a square or something like that, but it turns out, using like points like 3, 4, and 4, 3, it is a circle. If I change the equation a little bit, maybe make it 2x squared plus 3y squared equals 25. This equation would have a different solution set, and one of the points would be 2.5 comma 0. I'll graph those in red, because 2.5 would make this turn into 5. Negative 2.50 would also be a point on it. On the other hand, if I make x 0, I'd have to make y 5 over 3, which is about 1.6. So 0, 1.6, and 0, negative 1.6. So now the graph of the solution set's no longer a circle, but it's this shape, which is called an ellipse. An equation of this form is going to be an ellipse, and if I had an equation like this, I could graph it. I could just think of what the x-intercepts are going to be. So anything that makes this 6 and that 0 is going to make it equal 36. On the other hand, if the thing on the left is 0 squared and the thing on the right is 6 squared, that will work also. So this is 6 when x is 3, so 3, 0 and minus 3, 0. On the other hand, this other expression when y is 2 and x is 0. And when I graph these, you would see 3, 0 minus 3, 0, 0, 2 minus 2, 0, 0, 2, 0 minus 2 makes an ellipse. If I take this equation and kind of multiply it out, and then divide both sides by whatever's on the right side of the equal sign, and in this case things work out nicely, everything cancels out. I get x squared over 9 plus y squared over 4 equals 1. And when you see something look like this, there's an easy way to graph it, and I'll show you how that works. So if it looks like this, if we take the square root of the thing that's underneath the x squared, that's going to be, oh, and by the way, ellipses like this have 0, 0 as their center, just like a circle has a center, an ellipse has a center. This 3, we're going to go to the right and to the left this amount to get 2 of the points on the ellipse. The square root of the thing underneath the y squared is 2, so I go 2 up and 2 down, and then I connect to get my ellipse. In an ellipse, it doesn't have a diameter officially like a circle does, but it has two things. This long line is known as the major axis, and this shorter one is known as the minor axis. And the endpoints of the major axis are known as the vertices, while the endpoints of the minor axis don't have any special name. Now, had this equation been x squared over 4 plus y squared over 9 equals 1, now the horizontal left-right thing would be 2 and up-down would be 3, so this would be like this, and in this case the major axis would be a vertical line and the minor axis would be a horizontal line. If it looks like this, it's still an ellipse, but the center is no longer 0, 0. It is, take the opposite of these two numbers, so 1 comma negative 3 is going to be the center. And from the center, we're going to go left, right, the square root of 9. And we're going to go up and down the square root of 4. And we make our ellipse that way. Depending on how different the thing underneath the x squared and the y squared are, like if this is 9 and 16, or 9 and 16, let's say, it's going to look a little more like a circle than the other ones did. How close an ellipse is to a circle is called the eccentricity, or how far away it is from a circle, really, because when it's 0, it's a circle. There's a formula for eccentricity. E is going to be, now I didn't mention this before, but whatever the larger number down here is, that's called a squared, so the square root of it is called a. That's not always underneath the y squared, just in this case it is. And the smaller one is b squared, so square root of it is b. The eccentricity can be calculated with the formula a squared of a squared minus b squared over a. So in this case, we just subtract these two things, get the square root of 7, and a is not 16, but it is 4. So that's the eccentricity of the ellipse. Sometimes the equation of an ellipse is given in this kind of expanded form. That's 4x squared plus 9y squared minus 8x plus 54y plus 49 equals 0. If these coefficients are different, 4 and 9, and this is a plus here, this is a plus here, it's going to be an ellipse. And here's the way we do that. We factor the 4 out. Actually, first let me put the 8x together with the x squared, and the 54y together with the y squared, and bring the 49 over to the other side. Factor out the 4 from the x squared minus 8x, get x squared minus 2x, leave a little room here. Factor 9, 6y, leave a little room here. Complete the square, take the square root of 2, take half of 2, and square it, you get 1, that's what you put here. But you don't put a 1 on the right side, you put 4, because that 1 was really multiplied by 4. Over here it's plus 9, that's half of 6 squared, but it's really 81 on this side. Now we can factor x minus 1 squared plus 9, y minus plus 3 squared equals 85 minus 49, 36. Divide both sides by 36 and get x minus 1 squared over 9 plus y plus 3 squared over 4 equals 1. So it's an ellipse with center at 1, negative 3, and go left and right 3, up and down 2.